Welcome to Factorio. My name is Nesp, and in this video I will showcase my Factorio base. The idea behind this base came to me a few years ago, where I looked at some ribbon world videos, and I figured maybe I can make a mega base in a ribbon world, but then make it tileable. I spent some time building this base in a blueprint world, creative, and then I started a new save to create the base. And the idea was we have raw resources coming in, and then we have everything being made in between a set of beacons. So we have a copper ore coming in here, we have iron ore coming in, we have stone and coal coming in, we have some water coming in, we have some crude oil coming in, and everything goes in here, flows to the right, and we make more complex parts until we have all the science, all the rocket parts and all the labs, everything in between the set of beacons. The aim of one of these rows was to create 38.5 science per minute, which is what one assembler can do for blue science. That's the limiting part. And I made this because I like the challenge. One of the benefits of this is that as soon as you have the materials for it, you can just stamp down one of these rows. Of course, one of the downsides is that it's not that UPS efficient and that you need a lot of beacons and modules for this. Some other limiting factors that I said was everything that can have productivity modules should have it. The beacon should be speed, no belt weaving, and mostly flow from left to right. So as we go through this, we will probably see some parts that can be more compact or can be changed. But in general, the idea behind my design was if it works, then it works, and then I will not look at it again. So it's pretty fun to imagine that someone who spent thousands of hours on this is still lazy for some parts. So we start with copper ore going in. Uses filter inserters for no particular reason, except it's easier in an empty blueprint to see that copper goes here. And in the meantime, and throughout this entire video, all the other parts will just keep flowing underneath whatever we're working on. So we have some copper. As soon as all the copper is melted, copper ore is no longer on this on the belt, so it stops here. Then we have some iron, and ironically enough, we only need 6 iron assemblers, and the rest of the iron goes into steel. So here's some steel. The steel is not the ratio at all, because sometimes there are more iron plates being made than they are being consumed, and sometimes there's not enough iron. But overall, this is just barely enough iron or barely enough steel to keep the base running. And over an infinite number of time, the steel belt will very slowly start backing up, but that's very theoretical because I've played this save for quite a while and it hasn't backed up yet. So after all the iron and steel is smelted, we remove iron ore from the belts. The first thing we make is green circuits. We sideload those onto the belt here. I think it's a pretty standard design with direct insertion, and a lot of copper goes into green circuits. So after we made the green circuits, we can remove half of the copper belt and combine it with the green circuits belt. So you see from this point on, all the belts will be mixed. So we have copper with green circuits, and then we have stone with coal, and then we have iron plates with steel plates. We want to get rid of the crude oil, so we will create advanced processing. And we need to get some pipes in here, and we need to get some pipes in there. In order not to mix these, we use some very short underground sections so that we don't need to worry about mixing the fluids. And we also need to put this oil refinery to the side, because if we put it to the top like this and try to put it in between the beacons, then it gets very hard to put in all the fluids. You could do it, for example, like this, and then maybe you have the output something like this. Then you have a few spaces for belts, but I figured that out while I was editing this version of the video, so I didn't do it, and this works, so it's fine. We use the advanced recipe because we need all of the different parts. We need red oil, the heavy oil for lubricant, light oil we need it for solid fuel and rocket fuel, and petroleum for everything else. So everything still goes underneath. Crude oil goes off the bus. We make light oil, we make a loop, and if we have heavy oil left over, then we crack it and merge it together with the original. So there's no circuit shenanigans here, just whatever it needs to be first is made first, and then overflow goes further to the right. Here we have a direct insertion build for rocket fuel, goes on the belt and goes all the way to the end of the base, which we will get to in a few minutes. In the meantime, lubricant goes on. What's this? Light oil is being cracked into petroleum. Petroleum is being made into plastic with the coal. Coal is only needed here, so coal gets off the belt and makes room for the plastic. And this entire section of science, 38.5 science per minute, just needs one assembler for plastic. We direct insert sulfur into sulfuric acid, and we go on. We need 4 assemblers for advanced circuits, red circuits. They need 1 assembler for the copper cable, and this contraption right here is just barely not enough for the copper cables, so I added 1 long-handed inserter. We sideload the red circuits on the same belt as the rocket fuel. And in the meantime, you'll see all the snaking and spaghettiing going on, just to make sure that all the materials go where they need to be. Because as you can imagine, it's getting quite cramped in here, because we need, at this point, we have 4 different fluids being transported, and 1, 2, 3, 4, 5 different underground belts being transported, and then also the machines in between, the power poles, the inserters. It gets quite tight. The last bit of the plastic is needed here for the low density structures, which are needed for both the rockets and for the yellow science. So the plastic gets off the line, we fill it off here, and here it will make room for the batteries. We also have 1 assembler for the blue circuits, which are on the same belt here as the low density structures. Low density structure will flow through here. Yeah, there was one there. Batteries are here on the spot that plastic used to fill. And here we start consuming all the parts. So because we only need to make 38.5 science per minute, which is a limit that this machine here on the right can make for the blue science, the other machines don't have to be that efficient. So this one is quite efficient, but it's not working full time because it's faster than it needs to be. The output inserters are hooked up to circuitry to only output the science when there isn't enough in the system. So that's about 25 for all of them, and 250 for the blue science, and about 400 for the space science. Most of the builds are direct insertion. All the science gets put on the same belt, and if it's possible, the same side of the belt, but that's only relevant later on. You see that the line with copper plates and the green circuits is getting more sparse, but it's still slowly filling up. This is the main bottleneck of the base. This machine, as long as this machine keeps running at this speed, it's 38.5 science per minute. Here's another sulfur chemical plant that wasn't technically needed because it's way too fast for this, but I didn't want to bother making the sulfuric acid all the way from the left here and put it in here. I zoomed out slightly there to give a bit of a spoiler of what's next to come. The rest is direct insertion. This is one of the parts that I'm simultaneously very proud of, but also not at all because it's hideous, but that's the main beauty of it. So purple science needs a lot of rails. It needs 30 rails, and 30 rails need a lot of steel. I couldn't really figure out a way how to get the steel in here without being messy, because I also needed to put the stone in there. So I made this splitter here for the steel, and then I have two red inserters in a row, one picking up from the splitter and one picking up from the underground belt. And then I have two long-handed inserters inserting the rails into the purple science. That's not fast enough to have it running continuously, but it only needs to run about 60% of the time to match the 38.5 science per minute from the blue science. It also needs electric furnaces, which need brick, which is also one of the reasons why we have stone all the way up to here. And it needs some more steel. So the steel is being filtered off here with a series of splitters, so that also some steel goes on through the bottom. And then on the other half of this belt, because I filter off the iron here, we put some stone bricks with the shortest belt section ever in the history of Factorio, probably. The rest is direct inserted. Also the productivity stuff is direct inserted, with the green circuits coming from here in the splitter and the red circuits coming from here, this underground belt. I couldn't really figure out a way how to output the purple science, so I outputted it to the top for this brief belt section here, and then I long-headed inserted it to the bottom, and then together with all the other science packs that are coming through this underground belt, we sideloaded it on this part. So now all the science parts are on the bottom half of this belt: red, green, blue and purple. The next part is the yellow science. I couldn't really figure out a way how to put the yellow science in the middle of the system, so I offset it by 1, because I needed all the inserters for the other parts of the machine. But if it was to the side, then it needed just a tiny bit more speed, so I added 1 beacon here, right in the middle, so that this machine is quick enough. The other parts are way overscaled, but they only need to work occasionally. Let's see. It outputs the science on this belt, goes up, and then this entire belt sideloads on this part, so it's on the top side of this belt now. And in the meantime, all the other parts are still flowing through. Here we create a second part of the rocket. So we have the rocket control units. Just needs 1 speed module machine and 2 of these. We don't need red circuits anymore after this, so they make room for the solar panels, which we need for the satellite. We just need 1 machine for that, just as that we need 1 radar machine, 1 accumulator machine, and for the rest we need blue circuits, low density structures and rocket fuel. All of those things are already on the belt, which is right here. So if you look above my mouse, you will see that here are the blue circuits and the low density structures. The blue circuits can be picked up here, and the low density structures go on. They will be merged together here with the rocket fuel and go all the way to the right to the rocket silo, which is here, together with all the other parts, mainly the rocket control unit, which is now on the top half of the belt. It shared the belt with the science, and on the other half is the satellite. This machine only outputs a satellite if there isn't a satellite in this part, in the box in front of the rocket silo. So let's have a look. All the belts on top go into the rocket silo. The rocket silo is set to automatically launch with cargo, which is one of these satellites, and the satellite will only get inserted if this box has at least 400 space science packs. This beauty is how we do the research. All the science comes in through here, at least all the colored science, and then gets filtered through a series of splitters to be put into boxes. The content of the boxes is red, and that controls the output inserters for the science assembly machines. To get them on this belt, we set the stack size of all the inserters to 2, so that this belt is nicely distributed with all the colors. So let's have a look at the very slow speed. So this is 10% speed. So if you look at this belt, then it's not quite a compressed belt, but it's close enough, and all the belts are nicely placed next to each other. Okay, let's put this back to 1 and then clear this again. This inserter here is the saddest inserter ever because it tries to keep up, but it has only a very tiny space to pick up from the belt. So that's why there's a second inserter here on the bottom, so to pick it up, because the science goes all the way around, merges with the space science, and then here this inserter can pick up the space science as well as all the colored science as well as this. The space science gets filtered off, so the space science is only in the box and in this very small section here, and then the colored science goes back to the start of the sushi belt, gets siloed on so that the original belt has priority, and then goes back into the system. The science labs can consume exactly 38.5 science per minute. The left one can consume 19.95. That's because there are some extra beacons here in the middle for both of them. Because if I didn't have these beacons in the middle, then I would have to have one more lab, which I didn't really like. And the right one can consume 18.55. So together they consume 38.5 science per minute. And then to create the speed here from 18.55, we have the very last beacon have only speed 2 modules. So the rest of the base is completely filled with speed 3, except the very last beacon on the bottom and the top side. And for the rocket silo, this doesn't matter because this isn't limited by speed anyway. So that's most of the base. Now you've seen me pretty zoomed in because I wanted to have a nice surprise. This isn't the only row. There are multiple rows. I'm walking to the left as we speak so that we can see how I can supply all of these rows. So here's my little friend. So one of these rows is 38.5 science per minute. And then 8 of these rows is one, let's call it a system. And one system of 8 rows is fed with a couple of trains. So this is the input for all of the parts. 8 lanes of iron, copper, mixed of stone coal. Water is made here with some cheaty water fill, and then crude oil is also being fetched in with trains. I originally planned to put in water on the trains as well, but I didn't really want to bother with it because my train network was getting jammed. This is the train system. Separate lines for copper, iron, coal and stone, and crude oil and fuel are on the same line. We output from a cargo from a cargo train into a box, and from the box into splitters. This is the same for copper as well as for stone and coal. For the mixed belt, we read the contents of the box, and that goes into a series of combinators, so that we read it, divide it by the train size, subtract that from 2, and that's a train limit. So the train limit is either 0, 1 or 2, depending on how full the boxes are. The trains go to mine until they're full, and then they go here until they're empty or until some time has passed. I added this second part because somehow the draw from all the lanes was uneven. I think that has to do with the fluids not distributing everywhere equally. And only recently I've changed the iron ore design, because when you output from a box onto a splitter, it's a bit faster than just outputting on a belt, but it's still only 19.5 items per second, and we need 39.23 iron ore per second. So by outputting on the by outputting on the splitter we only had 39, so we needed a bit more. So originally I added this part, and then the belt was uneven, so I didn't like it. So I added one more box and inserter here, and I just copy pasted this design on top of the original design, and that was it. This doesn't really draw evenly because this one inserts on the splitter, so that one gets emptied quicker, but I didn't really care because it's a full belt and that's all that mattered to me. And that's also why I didn't really hook up the rest of the inserters and the chests. Let's see. Fuel gets inserted input in the bottom line here. Just a lot of boxes, a 1-4 train. The rest of the trains are 4-8. So 4 locomotives, 8 cargo wagons. And the fuel gets distributed with one roboport with a couple of robots. All the trains will always go to at least one of these stations, so they will always have enough fuel. So when the trains are done, they go to the right, and then they will merge on the main line. And the main line, if we go to the map, is quite long, because this base doesn't have just one of these sections of 8, but it has 26. So let's also take a look at the signal states. So every station has its own inline stacker. Here you see some of the signal states as well, so that you can see where I place my signals. You see that there are a total of 8 rail sections here. So the outer ones are for the crude oil and the fuel. This one, so the 2nd and the 7th, are stone and coal. Then we have copper ore, and then we have iron ore. So they all have their own small part. That's to ensure throughput. But even with all that, we still had some throughput issues. So you see that as we go further to the top, you will see that there are some remnants of more train stations. But I removed those because the train system was jamming. So I eventually turned to direct mining. So here's one of my Spidertron radar things. So I mined directly into some of the belts. And when you have a high mining productivity, you can do that with just one mine on each side, and then you have a nice compressed belt. So this design with some undergrounds and slightly offset miners ensures 8 belts right next to each other. I used some different design throughout, but this was the final one I used when I had plenty of mining productivity. I used a similar design for other parts. Looking at my other parts, I can't really find it. I will just send this guy over there. Because as you can see, also the copper and the stone is coming in, and they are being mined directly on top of each other. So where we just send half a belt of stone through and then mine the coal on the other half of the belt. You see this was made earlier when I didn't have the design. So here I have 2 mines for every side. So this one and this one are both mining onto this side of the belt, but that's more than enough. Okay. In the meantime, I will start going to that junction, and I'll just send my robots throughout so you can see the next part of the base. Sorry, that's one. So I'm supplying this entire base with my starter base. My second starter base, actually. My second starter base is here. I'll go through that in a bit. My first starter base was here. I've since deleted it because it wasn't that efficient anymore, and I've removed the chunks so that the UPS is higher. I have a huge solar field here. I have 1 million solar panels, give or take, and 1 million accumulators. There were radars here and roboports, but I've removed those for UPS. I supplied these parts with this. Not the most efficient, but it's nice to have something in line with the rest of the base. So we input 8 mixed belts of iron and copper. We We smelt them into iron, into steel, create a mixed belt. Same here with a mixed belt of copper ore and copper plates, and then we direct insert everything into the solar panels. And then we had a roboport here. We have that a couple of times. Similar design for accumulators, where we have copper, iron, and then all the oily parts. We have 3 of these. So originally I had 2 of these and direct inserted into here, but with the productivity, then we needed a bit more. So that's just barely not direct insertion, but close enough. And these were all flown out all over the map with roboports everywhere. I've since removed those. If we look at the roboport coverage, there's still some roboports here for my old base, and a separate network for all the train parts. Let's have a look. Put you there. This is me in one of the biggest junctions in the game. So this is what a normal block looks like, where the train go from one side to the other side, and then there's one branch that goes into a set of mines. And this just keeps flowing until the end of time, because occasionally a train needs to cross, but when a train crosses, then another train probably comes back, and then all the trains need to wait a little bit. But because there's so much room behind this, because the trains need to go all the way around, then this never jams. Let's have a look. Send myself there. Let's send you there. So in the meantime, while I'm going to the correct place and my other scouts are also going to the right place, you can just have a look at the scope of the base. There we go. Here's one of my mining setups. So you see that this is just a field that I created here because there was room for it. I mine directly into the cargo wagons, and on occasion this gets full. For example, this one will never reach a full state because one of these is empty. I think it's this one. Yeah, so this one is empty, so now this one will never fill up anymore. It doesn't really matter because we have plenty of mines, and all of the mines have the same name, for at least for iron. They have a train limit of 2. They have an inline stacker here, so there's one here and one here. And there's a chain signal right in front of the mine, so if there's ever a train coming here, then it repaths to the next mine immediately. Because in general, the train will pick the closest mine that's available, so most iron trains will go into here, unless there's already plenty of iron trains, and then to the next, and then to the next, and so on. Here's another example of a mine. Here's the same thing. The mines here were empty, so I figured out maybe I can do something by mining onto a belt and then inserting it into the wagon. That wasn't really UPS intensive, but it's also not that pretty and efficient, so I just added more mines and never really bothered with it again. You see the same thing here in the top one. And you also see that this is pretty slow, because this only gives half a belt. There used to be some iron here as well, but it's gone. Here's my second starter base. You see some remains from the original starter base, and also some fuel and some efficiency modules that I started experimenting with. This is the entire nuclear setup. So a couple of mines. Get transformed in the good and the bad uranium, only if there's not enough in the boxes, and otherwise it just stops the belt here. Gets transformed, gets coverexed into the better ones, and then gets processed further into nuclear fuel together with some of the oil from here. I think these are all pretty standard setups with 8 beacons and 8 machines in the middle. We have a robot mall with logistic bots and logistic chests. We have some more steel here being made because it didn't have enough. Here we create some more solar panels, because at first this was a solar panel design, but I figured this wasn't enough, so I added more in the top left. You also see this direct insertion here. And you also see that the ratios are pretty off because there's only one machine for the accumulators and 4 for the solar panels. But together with the 4 of each in the other part of the base, then it's closer to the ratio that we need. So more parts for the belt. At first I wanted to make everything with belts, have a belt mall, but I got bored and just placed down robots. Some more parts for the belts. So here I create iron gears, 4 lanes in total, and then I distribute those to the rest of the base. Here we have modules, speed and productivity, all in line from the circuits. We have circuits, we have more circuits. Most of them have filter splitters for the inputs. And then we have some smelting here. Some more smelting. And here we have the oil design. And I think this is the oil design of Nilaus, because I couldn't really bother making another oil design. Okay, let's see where's some other parts that I didn't showcase yet. So these are the mines. I showed the mines, I showed the solar panels, I showed the second starter base. Fun fact, there's only one oil train station in the entire map, because this gives more than enough. I think there's about 10 of these trains. Yeah, 10 oil trains, and they are more than enough. And as soon as one leaves, the next one is full instantly. Some of the oil is now being made, for example here, where we have some pump jacks, just to alleviate some of the pressure from the train network. So let's have a look at another part of the base with another view. So this was with the logistic networks. This is with the electric networks. So this is the solar panel field. This is the base. I've skimmed over it, but I also experimented with putting solar and accumulators in between the rails, just like Zisto did in one of his bases many years ago. But that wasn't really enough as you compare the size of this with the size of the field. No turrets, no pollution. Train stop names are all identical for all the parts. One thing that I didn't mention yet was for the copper and stone, I put them right next to each other. So I have filter inserters picking it up, and I also have the trains leave the station if there's nothing going on. I think they leave after a minute or so that there's always room for the other type of train. Let's have a look. Let's have a look at the recipe icons. So this is what it looks like to look at my base from a distance. Very nice. Everything in line. For the video, I've added these radars, so you can have a look at what this looks like. And you see that if I just sit here and then press W to go up, then you see that all of these are mostly working. So let's have a look. There's a rocket being launched right there. Let's have a look at what our statistics are. So let's look at 10 minutes, for example. And let's look at science. You see that the science being made is all over the place. Doesn't really matter because it can only be consumed at a rate of 38.5 per row. But we have 38.5 rows times 8, and then we have 26 of these. So 26 times 8 times 38.5 is 8008. So we can have a maximum of 8008 science per minute. We are now around 7800, 7900. It varies a little bit. Sorry, let's put science back. It varies a little bit, but in general it's relatively stable. You see that if we go to the 50-hour mark, see that it's slowly becoming more stable as we go on, because I've been bug fixing a little bit. and I've been alleviating some of the pressure from the train network. I think I spent about 200 hours in the entire save. Not building full time, sometimes just AFKing or letting it run for a bit while I looked at it. Let's have another look at some parts. So the electric part. So we have 1.1 million solar panels and 950,000 accumulators. We have 69 gigawatts of power. It's plenty. Let's take a look at all, and let's take a look at some of the parts. So we have a few copper cables made and a few iron plates made. Let's take a look at the belt. We have 500,000 blue belts made and 125,000 underground blue belts. Only a few splitters in contrast. Yeah, for the rest are I think pretty standard numbers for a base of this scale. Let's take a look at what's drawing most of the power. So the most power goes into the assembly machines, then into beacons. We have 30,000 beacons, almost 10,000 assembly machines, 8,000 furnaces, 2,000 chemical plants, 36,000 stack inserters, and so on. We also have 208 rocket silos, which was also fun to craft. Yeah, the rest I think speaks for itself. So this is the base. While we were talking, we've researched a little bit more mining productivity. This train network just goes on and on. I haven't seen any jam since I started removing trains, so that we have more stuff on the belts. Most of the belts are here. It's pretty UPS safe, this part at least, but the train part isn't. The rest of the base also isn't, because a lot of the belts are not full at all. And they're also mixed, and there's also some circuitry involved. There's also this sushi shenanigans going on, which looks awesome, but is not the best for UPS. So some small fixes that I did to get this base running to near 100% capacity was the train jams that I spoke about. There was a missing belt somewhere here. I removed the radars and the rotor ports. I did the extra inserters for the trains, and I mined directly into the trains. Some possible upgrades for this is to have larger trains to maybe unload 16 or 32 belts at a time, so that you can merge some of these parts together. We could also mine more parts directly onto belts and just belt them in. We could slightly redesign some of these parts, because I can, while making this video, I've already seen some parts that I can definitely improve, but I figured it works, so I'll just leave it. I also didn't leave any room for roboports in here, or for radars. So to create this, I had to sit in my Spidertron here like such, and just go into my base to load up, and then control click, and then control click back and forth a couple of times, shift click, sorry, like such, and then go back to my base, click a few times, and then yeah, this was the gameplay in the end. That was a bit too slow, so I added the second part of my robot part. So this is a set of identical Spidertrons, and they all have they're all following the leader, and the leader just goes somewhere, and then they all start building. They have materials for roughly the correct ratios here, so that they can also build. So then we can do it like this, and then we just paste blueprints, and the blueprint pasting was done with this guy. So this was my mobile radar, and I just placed this on top there, and then I just left the computer while this was doing its thing. This wasn't really the bottleneck, because when I was doing this at full speed, then the module producing parts were not able to keep up with me placing them down that fast. So let's also take a look at how many modules we have, because I didn't show that yet. Let's have a look at all. So we have oh, sorry, here we are. We have 80,000 speed modules and 62,000 prod modules, and also a couple of million of each of these, which is quite a reasonable number. Yeah, let's remove this. Oh. Yeah, here you see the blueprint that I just copy pasted. I accidentally selected it here, and then I need to align it somehow with one of these parts. There we go. So as soon as this turns blue, then I can shift click and then drag it on top. So this was quite a nice design. Some other possible upgrades were including the roboports and the radars in the design itself. So I can just copy paste it from the base, maybe make the starter base or the base here, so that it's created automatically instead of semi-automatically. I can change some circuitry, but that's also slight efficiencies. Maybe I can add military science. Maybe I can do the same for C-block. But I think for now, at least for this base, I will wait for the expansion, see what quality can do, or what other improvements can do, other buildings maybe the foundry, other buildings. And maybe there's a way to improve this base with quality. But I think at least for the expansion, I will create a new base all the way from scratch and see how far we get. For now, thanks for watching. Let's have one more overview of the base with recipes, without recipes, with the trains, and with his final parts, where all the trains just keep flowing back and forth. Thanks for watching, see you next time.